Day 15, Warehouse Woes. So I'm going to get a grid and a series of moves. And so the grid is going to have walls around the edges, and they can be in the middle too. That's the pound sign. And then there's going to be crates, which are the O's. And then there's going to be a robot, which is the at symbol right in the middle in this example. And basically, the robot is going to take this series of moves where up, down, left, right. And if it can push a crate, it'll push it as far as it'll push it in the right direction. If there's three crates and then an empty space, it'll push all three crates into, over to one to the left. But if there's a wall, it can't run into a wall. It can't push crates into a wall. So I kind of have to keep going to like make sure there's an empty space and then push the whole column or row over. And that is basically it. So you can see, if it runs into a wall, it doesn't move. If it moves up, it moves. It can't move up again because there's a wall. It does move over and it pushes the crate. It moves again and it pushes both crates. It can't move this time because both crates run into a wall, so it does nothing. It pushes 4 crates down. It does nothing because those 4 crates run into a wall, etc. And at the end, I need to get every crate and multiply its row times 100 plus its column. And that's my score. Let's go ahead, and if I can find my VS Code window and jump in, I will do a GenDay script here for day 15. This pulls my input and gives me a stub to work from. I'm going to grab this example text as well, so I have it. Come here and sample, paste that in, and close you. Let's take a look at the input. It's large, but it's not huge, so it looks like it's like 50 by 50, and a fair number of moves. It does look like I have new lines in the move, so I'll have to take that into account. Cool, let's go ahead and take a look. So to parse the grid, we are going to want a list of, we want a modifiable list. So we can't have a list of strings, we need a list of lists. So we're going to do, and we have 2 different things. So we'll start by saying grid string, comma, moves equals f.read split on new line, double new line like that. And then when we'll say grid is equal to list row for row in grid string dot split new line. So we effectively are going to take each row, we're going to turn it into a list. We also need to remove, I mentioned those, let's get rid of those moves equals moves dot replace new line. I don't want to run into these later. I'm going to get this before I forget about it, and we'll just replace it with nothing. So what do we need to do? Well, we need to find what the robot is. So we can do a simple for our row in enumerate grid for c comma val in enumerate row. If val is equal to this, we will break. This is actually a neat trick. I just want to save R and C. So when this is a trick I learned watching other Advent of Code videos this year. I can do an else continue break. And so basically what's going to happen here is I'm going to run through for each row, I'm going to run through. If I find val, I break. And when you a for loop, so that'll then hit this break and exit. Whoa. If I don't find val, I reach the end of the for loop, which the else runs, which continues, which goes to the next row. So this break will only hit if this for loop was broken. And so basically only when I find val do I break. And now I've got R and C. And I'm going to use that, that R and C will be my robot position. So now I need to do my moves. So let's see. Come down here, we can say for move in moves, and move is like are like arrows now. So I'm going to say move map equals, and then we'll just say left, and that will be, so that'll be 0, -1. If I go up, that will be -1, 0. If I go right, that will be 0, 1. And if I go down, lowercase v, that will be 1, 0. So now I can say dr dc equals move map of move. There you go. So now I've got my next thing. So we'll say rr. I'm going to need to loop over spaces, and I don't want to move my robot. So I'm going to start like with a new, I'm going to call rr and cc is equal to r plus dr, c plus dc. And now I'm going to say, I need a way to store, so we'll say while true, if grid rr cc is equal to a pound sign, then we've run into a wall. None of the move can happen. So we'll say we're gonna break. We're gonna get out of this loop. But we also need some way to record that we're not gonna move. So we'll say do move equals true. We're gonna assume it's gonna be true, but when we hit this, we'll say do move equals false. So now we're not gonna move. We can do if grid rrcc is equal to a dot. So now we know we actually reached a space. Everything that we want to push can be pushed. So we can also break here, and we'll leave do move is true, and we're out. Otherwise, if let's see, grid rrcc is equal to O, I could probably do an else here because everything in here, but I'm just going to leave this here in case I make a mistake. This will be helpful. Equals. So we're gonna, so anyway, if we hit a pot, we're gonna need to check the next one. So RR plus DR, CC plus DC. We move, and that's basically it. Actually, I can do like an else, assert false, just to make sure we catch that. And so now at this point, we will have moved, and we'll have figured out if we can do the move or not. So say if not do move, continue. So if the move wouldn't work, just move, go to the next move. We don't do anything. Now, move did work. We need to figure it out. So R, comma C, let's see. First thing we're going to do, we're going to say grid of R, comma C is going to be empty. The robot has moved out of it. We'll then move the robot. R, comma C equals R plus DR, C plus DC. Now we need to, let's see. If grid, so we need to, we want to check, before we update where the new robot, so we're going to say grid RC is equal to our new @ symbol. So now we've moved the robot. Before we move that robot, we need to check, because if we, let's see, so if, let's make more sense as I show it, if grid RC, so the one we're moving into is equal to space, is equal to a crate, then we need to set we basically can pick up, where's my example here? If I'm pushing these, if my robot were here and I was pushing left, if this next space is a space, then I'm just going to move the robot and be done. If the next one's a thing, then I need to move this one. I could move them all one by one, but I can also just pick the one and move it to the end to that dot. So that's what I'm going to do. So if that's a thing, I'm going to say grid RRCC, which is the dot we found, the last dot. We always are going to break. If we're at this point, we've broken on a dot. So that point is equal to O. And then no matter what, we're going to move the robot. We have to do this one first because otherwise we'll have messed up. We'll have already overwritten this and we'll have lost it. I think that's basically it. Let's see. So let's take a leap of faith here and see what it looks like. So we can do sum. We need to do R times 100 plus C. For, I always forget the order, so I think it's R comma row in enumerate grid, for C comma val in enumerate row, if val equals O. So we are going to loop over every row, every column, and if the value is equal to O, then this thing is going to be, then we're going to have, or only if the value is equal to O, are we going to store R times 100 plus C, and then we'll sum all of that up, and we'll get part 1. Python, oops, let's do day 15 example, and would not have expected this to run for very long. Did I save example? I did. No, I don't. I said I'm equal to. I said silly one. Okay. Where's that print? We don't want that print in here. Keep it pretty. Example was 1092. That doesn't seem right. Oh, it is right. There's some here. Okay, so we got that. Look, that matched rightly. Let's patch here, and we got a number, and it's the right number. Sweet. Pause to read part 2. All right. Part 2 is we are going to. It turns out everything is actually double wide, except for the robot, which is weird because everything except the robot is twice as wide. The robot size does not change. So whenever we have a tile, we actually have to put 2 things. Whenever we have this, we have to put 2, or have a crate, we'll have left and a right. Whenever we have a tile, we have our space, we have 2 spaces, and the robot just is on the left space. And now it points out here. So if we push a crate this way, let's see, let's find some crates here. So if we push these crates here, you can see that now we have, looking at this one, the crates can get misaligned or not always like aligned one-to-one. And so if I push this up, all of them will move. Because if anything would move it, it just moves. So we could potentially have some, so we can't just check the single end now and break. We have to get to where everything here is, everything that needs to move is movable, and then we go. And we do basically the same thing except for that. So I think, as far as I can tell, I think we have to throw the whole thing out here. Because, I mean, from the very beginning, we're just changing the grid. So, I guess we'll just do I hate not having a single file that runs them, but for now, let's do day 15 to day 15-2, and we'll come into this and start working. We're gonna make some changes. So, what are our changes? First thing we need to do, I'm gonna need grid map is equal to, and we need to map these things. That the O is gonna go to like this, dot, gonna go to dot dot, and my robot is here. It's going to go to robot dot. I think that just is there to keep the grid evenly spaced. So now we're going to read this in the same way as we did before, but we're going to get rid of grid here. We're going to have to change grid. I think this one's worth doing in a loop. So I'm going to say grid equals that for row in grid string dot split lines. And we'll say new row is equal to the empty row. We'll say for val in row, new row dot extend by grid map val. And so extend says take a list of things, an iterable, and just add all the items in it to the list. So when I extend, I will get when I extend by pound, I get 2 entries, pound and pound. I don't get a single pound. If I did append, I'd have a single entry that was a string that was too long, pound. When I extend, I'm going to get 2 entries, pound and pound. Hopefully that makes sense. And then whenever I finish with a row, I need to grid.append new row. And I think that'll work. I think we should get that should give us our new grid map nicely here. We're still going to need to find our robot just the same as before, so we can leave that the same. The move map will be the same, but I think the way we approach moves is going to have to change completely. So we're still going to, I need to keep a list of things I want to move. So I'm going to say to move is equal to, and I'll add r comma c. So the first thing we're going to check is we're going to check, can the robot move? I'm going to keep an index. We'll say equals 0, and we'll say while I is less than len to move. So basically we're going to loop through the thing, continuing. We can't use a for loop. Oh, we can use a for loop here, but it requires making some, we'll have detail checking that I don't want to bother with. So what I'm going to do is I'm going to just do a while loop. I'm going to start with this list. I'm going to be adding to this list, but as long as my I stays less than the length of this list, I'll be fine. I do need to make sure I don't add double items to this list, but I'm doing this in order, and a set is not ordered, so I can't use a set here. So I'm just going to have to check that. So remember to check that. So, so now I got for each thing. So I'm going to say rrcc, the new thing I'm checking because I don't want to mess with R and C, equals to move sub I. I'm going to get that. I'm going to go ahead right now and say I plus equals 1, so I don't forget. No matter what happens, I've now got this item. I'm ready to move on to the next I. Okay, so we'll say nr nc is equal to rr plus dr cc plus dc. So the next space, I need the place I would be trying to move. So I'm trying to check, can I move this to move? So if it is, let's see. So if it's already in, if nr and c, that next space, is already in to move, means I've already checked it. It can't be moved. It can be moved. In to move, then I will just continue. I don't need to check this again. I probably should check, but, well, we're just going to stick with that for now. Then we can say, if the grid of the next space and the next space is equal that, do move is equal to false, break out of this loop, we're done. We're going to continue down here. We found something that can't. If the next space, so we'll do nr nc is a dot, then I can still, I'm done this, then this check is good. But I can't break here because I don't, there could be other things that are good, but so I'm just going to continue to the next, i's going to move to the next I in the loop. Now, if the loop is, if I've reached the end of to move, then great, I'm good. But if there's other things still that I need to check, then I can do those checks. Oops, that's not where I needed that. Talking and typing at the same time. Continue. If I reach this thing, if I reach a left side of an edge, then I need to add to move.append. And what am I appending? I'm going to add nr, that row, and I'm going to add nc. I guess I could do an extend. Show that off here. Let's see. And I also need to add the next row and the one to the right of it. So that'll be nr plus nc plus 1, like that. So both of those things get put in the queue to check. And then likewise, I need to do elif grid rrcc equals this to move dot extend nr nc comma nr nc minus 1. So I'm going to add I'm adding both parts of that in. And again, I should cover everything. At that point, I should not ever hit this. So now when we get down to here, we're gonna, if we broke out and don't move, great, we're good. If we are going to move, I'm gonna need to make a copy. I'm gonna move this grid around, but it's gonna revolve on what I'm doing. So I'm gonna make grid copy equals list row for row in grid. So I'm just making myself, I can't just do equals grid because then I'll get a copy of, I'll just get a pointer pointing to the same objects in memory. But by calling list on a row, I'm getting new, that returns a new list. And even though that list is already listed, it just makes a copy of it. And by looping over it, I get a copy there. So this is a good clean copy. I guess I'll move the robot. So r comma c equals r plus dr c plus dc. Oh, I literally already had that. Okay. I want to make sure anything moving potentially leaves behind an empty space. So the first thing we'll do is go through over for rrcc in the move. And I will say grid rrcc equals dot. I'm going to empty all the spaces that are being left. Now, some of them are coming in. What I can't do is come in here and then put the new spaces in now, because then I might be it might be overwriting things. I'm just going to do empty all the spaces that are being moved and then put all the things into wherever they're going. So we're going to do another loop, and because this is small enough, it doesn't matter. To move. And now I'm going to say nrnc equals dr. I don't think I need it. I don't think I need to bother with that. I can just say grid rr plus dr cc plus dc is equal to grid copy rr cc. So I'm going to loop over everything that's needing moved. I'm going to get what it was in the original grid before I zeroed it out, and I'm going to put it where it goes having moved. And that will include the robot, because the robot's in there. So I don't know, did we just solve it? Let's see. Part 2 is this, part 2 is this, part 2, get rid of all of you. I'll probably combine these into one file just because my OCD likes to have one file that prints part 1 and part 2, but it's literally going to be all of this with all of the other one minus the sys. Okay, so we're going to loop over. We're not looking for val this, we're looking for val equals left edge, they said. And I don't know, this is a lot of stuff to do in one go, but let's see if we get anything here. We asserted false. That's a bad sign. Let's see, in our example. All right, in doing all of this, I found 3 problems. First, this is just wrong. This needs to be nr, nc, and nc. These right here. That's why I'm checking my self because I'm not checking the wrong point. 2, extend is going to fail here. I need to fix this. This looks like this. And 3, this is a really dumb typo here. This is actually the first thing I noticed. C plus, that should be DC, not D there. And when all of that comes together, let's see if we can do it. On Python day 15, this is just like really dumb typos. I don't even know what I'm doing in here. Python day 15 to ext 9021. And that is the right answer. So it turns out making dumb errors, we'll do that to you. So if we do input.text on that, we get a pretty large number, but it is the correct number. Yeah, I guess that's it. This was kind of painful. I'm mostly because just like troubleshooting, like just looking through. I think I'm cutting a bunch of me fumbling around stuff. I did do a little bit of like debugging and stuff, but I don't think it was a very interesting video, especially when the only problem is I just made dumb typos. So, thanks for hanging out with me today, and I'll be back tomorrow. Bye.